So you'll see here that there's a 0, 0, 0, which is converted back to x. Yeah, the O at the bottom is at the edge. That's why it still remains at the, like an O here, right? So only those that are surrounded by x and it's not in the edge, right? That's the time you convert the O to x. Okay. I think this problem is like similar to the number of islands where we try to connect all the islands together and then it's on the edge, you don't basically bother it. Okay, I can think of a few ways to do this. One is obviously you could do a tool pass for each of the node. You check first if there's a edge connected to it and then you run another pass, but I think that solution is a bit slow. So let me think. Maybe okay. I think you could, what you could do is, why not just scan all the edge, right? Because he's trying to find out all the edge, right? Scan out all the edge. You basically don't want to flip that, right? So you can put a different letter from it, and then anything that are O in the middle. So when you scan it again, anything at all, you just convert it back to X, right? So you can start from the edge, find all the edges, and then do a DFS and then convert that to some sort of letter, and then later on when you scan it back again you flip it back to O, right? Because basically you want to exclude it, and then all the ones that are in the middle is probably will become X. So yeah, I think we could start doing that approach. Yeah, we need a DFS function here, which if you're not familiar with DFS is the depth first search, where you go to the deep into the borders, because it's the adjacent border is like up, down, left, right, right. So the way it works is from one position you go to the left and then you go to the leftmost part, right, until you get to the bottom, and then you go up, like going to the depth and going back up, and then go to the right, then go to the top, and then go to the bottom. So you do need to move your pointer, so you do need X array, which is like up, down, left, right, right. So you're moving X is X axis and then Y is Y axis. So do something like this, YR. So what is the X axis for? X is like the row. So you go up and you go down, and then 0, 0 here. And then from the Y, which is a column, which is basically up, down, left, right, 0, 0, and then left is -1 and then 1, right? This is basically up, down, left, right. And what you want to do is you're gonna go down recursive. That's how the FS work, right? You just go recursively, keep on going to the left, keep on going to the right, until you get to the very edge, and then you go back up again. So yeah, we can try to write the DFS code first, and then we'll do the edge later. So the DFS usually is basically you need to have a for loop here for 0 I is less than 4 I plus plus, because you need to there are 4 directions. So like your X position is basically X plus XR, or and then your I here. The Y position is basically your Y position plus YR here. And this is a pattern for this, but there's one way of doing it. Kind of like I'm scanning through all of my array and then going through each one. And then we have to call this DFS method, where the board is basically the same, which is the board, and then your position now is X pose and Y pose. Right, so every time we do this, we need to assign the board to assign it to some value. Just make it 100, and just to make sure that we haven't touched that part. So your M is board length, right? M is the length of the board, and N is the length of the column This is board 0. Right. And so yeah, we need to put a if statement here to make sure that we don't go over past the board. So it's like if on the edge is like expose is should be greater than or equal to 0, right? And y pose is greater than or equal to 0, and expose is obviously less than m, and y pose is less than n, and board expose y pose is it should be O. But that's the only time you go down if it's you go deeply if it's an O, right? And then we call this method again recursively. Okay, I think we can call this method, right? So will this work? I think we can try. Let's put a for loop here. So this is like a you still have to go through your board for each of the len of the board, which is a len. Okay, let's just I plus plus. Okay, just copy this. Sorry, just copy this. Okay, sure, copy that. For j is 0, j is less than n, and then j plus plus. But I think what we want to do is we just want to go through each of the edges. So the edges is if I is equal to 0, or j is equal to 0, or I is equal to m minus 1, or j is equal to n minus 1, right? And if it's if the board for that position is an O, right? Yeah, if it's an O, you call DFS, just mark it as 100. So basically, we're just going to go there and then mark for each of the position, mark that as 100. So we have to do another pass here. So we just copy this and then check if j is 100. We basically assign it to O, right? Because we're switching it back to O. There's some number here, right? Else, if the board is j is equal to x, we assign it to oh no, is 0, it's O, then we assign it to x, right? Because we're switching all the O to x. If that is something in the middle, if that is something to the side, on the side, right? I think this is it. Let's try if this is gonna work. Okay. Board ij. Okay, this one. Okay, first run it works. Right, submit it. But we're kind of like running on the side. Okay, there's another way of running this. That is, let's say if you don't want to do it for the edges, you just go for everything, and then you just see if that particular position is edge. You do a DFS, assign another number with it. Right. Okay. I think we can try that version. Like I'm not sure. I think it's probably slower, but we just call it DFS2. DFS, whatever. Let's remove this part here. I'll just comment this out. So if basically if if x is equal to like 0, or y is equal to 0, or x is equal to n minus 1, or y is equal to n minus 1, we know that it's an edge, right? So we just return false. Return true. Like we found out that yeah, we're connected to the edge. From here, what we need to do here is yeah, we check the board if it's 0. And then we call this method again. Basically, this is a bool. Check if that position is an edge. If it's an edge, you just stop, right? You just stop. So we just return true here. Basically, the exit condition is actually if it's not an edge, everything is false. So we know that there's an edge. Basically, telling our board like, okay, I found something that is on edge. And then we can assign it from other than 100, probably assign it to 99 or something. Yeah, this is initially assigned it to 99. This is a 2-pass call. I think this should be slower than the initial solution, but it should also work. Like you can try to do something like this. So now you don't need to go for each of the edge. You just basically check everybody, check each of the node. Okay, do a call like, okay, if I found that it's an edge, what you need to do is call another DFS. Yeah, we call another DFS. Then we're assigning to 100 now, because initially that 99 is for the first pass, right? So now we're gonna assign everything to 100. So if its board is equal to like this or 99, so basically we now have another check here. If it's board like this or board is equal to 99, okay, but that way we have to have a edge condition like this one also to make sure that it doesn't go overboard. Like if it's like this, then we just ignore, right? We just keep on assigning everything to 100. Like we just go DFS, check if it's 0.99, make all of it to 100. Now if you see like edge, if it's 99, like if it's 99, then you make it 0x, because yeah, eventually everything will be 99 here, and the second pass will convert it to 0. So let's try this out. It's gonna work. 99. Okay, missing one. Let's close it. Okay, it's not working. Okay, it converted the other way around. So I think it should be, when you see it should be X, see 99 should be O. Sorry, you're right. Okay, let me check. Let's check. What's the problem here? Okay. Okay, we missed something. Like if we need to check if the board actually is an O, right? Because you only want to bother about those that are to O. Yeah, put that in here. Okay, and then I think this is incorrect, right? It should be O and X. Let's try it out. Submit it, see if it's gonna work. Okay, we have a problem. The problem is, why did this one becomes X? So you notice that all the up, down, left, right became x, and O will become eventually 99, right? So you know that it's a 99 or a 0, then we need to assign that to 100, right? So I don't know why it's an x here, because this will become true, right? This should be true. So I think we have a problem here. So let's try to separate this out. Then let's just do it like this. Put an if here. If DFS, first DFS should be true. Try to put a print. Put a print in Golang, right? So empty. fmt dot print ln. I should print here. Just anything, right? Yeah, just forward ij. Just print forward ij. See how it goes. So value here. So this should be 99, I guess. Change the 0. Yes, 99. Did we assign anything? Okay, here we are. Here's the bug. Here should be DFS2. Yeah, there you go. I think should fix the problem. Okay, just always be careful with the naming. It's a bit confusing. Kind of like sometimes it breaks up. You do have a little bit of advantage because you're not scanning from the. It varies actually. So I won't really. I think it's almost the same as the first algorithm. So yeah, I think if in an edge you assign another value to it, like 100, so that later on you can switch the 100 to 0. Yeah, yeah. So basically, if it's not, then it's 99 is like the x. This one is more like a forward way. The other one is like the other, like the negative way of doing it. Yeah, but both solution I guess will work. So yeah, I think that's it. Thank you for watching. If you like the video, please hit like, subscribe. Thank you.